Find the distance from point A to line BC. Because line segment AD is perpendicular to line BC, the distance from point A to line BC is AD. Because the distance from a point to a line is the length of the perpendicular segment from the point to the line. So looking at the picture, you can see that line segment AD is the perpendicular segment from point A to line BC. So you will use the distance formula to find AD. So AD equals the square root of the quantity -1 plus 4 squared plus the quantity 8 minus 2 squared, which equals the square root of 3 squared plus 6 squared, which gives the square root of 9 plus 36. Adding 9 and 36 gives 45, so you have the square root of 45, which is about 6 7/10. So the distance from point A to line BC is about 6 7/10 units. Prove the perpendicular transversal theorem using the diagram and the alternate interior angles theorem. The perpendicular transversal theorem states, in a plane, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. So you are given that line H is parallel to line K, and line J is perpendicular to line H. Prove that line J is perpendicular to line K. Begin with the statements and reasons table. Line H is parallel to line K, and line J is perpendicular to line H because this is given information. Then notice that the measure of angle 2 equals 90 degrees. Because this is the definition of perpendicular lines, and you know that line J is perpendicular to line H. Then angle 3 is congruent to angle 2 because of the vertical angles congruence theorem. Angle 2 and angle 3 are vertical angles because their sides form two pairs of opposite rays. Then angle 3 is congruent to angle 6 because of the alternate interior angles theorem. Angle 3 and angle 6 are alternate interior angles because they lie on opposite sides of the transversal and inside the lines H and K. Then angle 2 is congruent to angle 6 because of the transitive property of congruence. So because both angle 2 and angle 6 are congruent to angle 3, then they are congruent to each other. So the measure of angle 2 equals the measure of angle 6 by the definition of congruent angles. So the measure of angle 6 equals 90 degrees because of the transitive property of equality. So because the measure of angle 2 equals 90 degrees and angle 2 is congruent to angle 6, then the measure of angle 6 equals 90 degrees. So line J is perpendicular to line K by the definition of perpendicular lines. Thus you have proven the perpendicular transversal theorem using the diagram and the alternate interior angles theorem. The The diagram shows the layout of walking paths in a town park. Determine which lines, if any, must be parallel in the diagram. Explain your reasoning. Looking at the diagram, you are given that line A is perpendicular to line D and line B is perpendicular to line D. So line A is parallel to line B by the lines perpendicular to a transversal theorem. Because this theorem states that in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So in the diagram you were given that both line A and line B were perpendicular to line D. So this means that line A must be parallel to line B. The